Welcome to my presentation. In this presentation, we shall see examples using properties of logarithms. Let us say we want to solve a logarithm equation. We want to solve a logarithm equation in this example. We want to solve for x. If the expression given to us is as follows: log x to the base 10 plus log x plus 9 to the base 10 is equal to 1. Okay, if we have something of that nature, we can solve this example using these different steps. We know the product rule. The product rule of logarithms is telling us that if we have log x times y to the base b, we can expand it out using the product rule as log x to the base b plus log y to the base b, right? So if this side is true, this expansion is true, this contraction is also true. So therefore, since we have the given expression as this type, we can shrink it to this form on the left hand side. So I'm going to write this given expression log x to the base 10 plus log x plus 9 to the base 10 equals to 1 as this type now. So therefore I can write it as log x times x plus 9, this whole thing to the base 10 is equal to 1. Okay, that is our first step. In our second step, we know we can expand or we can express a logarithm in terms of an exponent. So if we have log x to the base b is equal to y, we can write this one as x equals to b to the power of y. Okay, so therefore we can now come back and then write whatever is inside the brackets as x times x plus 9. Let me write this a little bit more clear. X times x plus 9 is going to be equal to 10 to the power of 1, which is same as 10. Now we can expand this part, expand x, or distribute the x to every one of the terms inside the parentheses. And when we do that, this is how it's going to expand. X times x is x squared, x times 9 is 9x, and then 10 to the power of 1 is 10. And if we were to bring everything to one side of the equation, it is going to look like this: x squared plus 9x minus 10 is equal to 0. This is in the form of the quadratic equation, which is of the form ax squared plus bx plus c is equal to 0. And in here, the value of a is equal to 1, the value of b is equal to 9, and the value of c is equal to 10. So we can use the quadratic formula to be able to find the value of x. So in here, let us identify the values of a, b, and c. The value of a is 1, the value of b is 9, and the value of c is negative 10. So using the quadratic formula, how does the quadratic formula look like? It looks like this: x equals to minus b plus or minus the square root of b squared minus 4ac, this whole thing divided by 2a. We know the values of a, b, and c. We can substitute into this equation and find the value of x. So let's do that. Minus 9 plus or minus the square root of b squared, 9 squared, minus 4 times a is 1 and c is negative 10, this whole thing divided by 2a, 2 times 1. Therefore, when we expand this, it's going to expand as follows: negative 9 plus or minus the square root of 9 squared is 81, and then negative 4 times 1 is negative 4, times negative 10 will be positive 40, divided by 2 times 1 is 2. So therefore, negative 9 plus or minus square root of 121 divided by 2. 81 plus 40 is 121. Therefore, the square root of 121 is 11, isn't it? You can use your calculators, and then you'll see that the square root of 121 is 11. Negative 9 plus or minus 11 divided by 2. So the value of x, it will have two values. One of the values is x equals to negative 9 plus 11 divided by 2, and therefore when we simplify that, it is going to be positive 2 divided by 2, which is going to be equal to 1. Therefore the value of x equals to 1 is one answer. And let us see what the second answer is. The second answer here is x is equal to negative 9 minus 11 divided by 2. And then that is going to be negative 9 minus 11 will be negative 20 divided by 2. And therefore the value of x will be equal to negative 10. So we have a positive answer and we have a negative answer. As far as logarithms are concerned, logarithms are defined only for positive numbers, not negative numbers. Therefore, x equals to 1 is the true solution for us, and we're going to discard the value for x equals to 10. We're going to discard that. We're going to just pick this value here. This is the way we want to be able to solve a logarithm equation. In my next presentation, we shall see more examples using properties of logarithms.